In this video, I'm going to talk about graphing lines and along the way, just kind of cover some key points about lines too. So first thing, if the key idea with graphing lines is that you can find any 2 points that are on that line, because once you know 2 points, that determines the line. Like there's only one line that will connect those 2 points. So if we have this as our example, y is equal to 2x plus 4, it means we're trying to figure out an x and a y that will make this true. A way that I think is often kind of the quickest is if I set up a little table. So I've got my x, I've got my y, and I'm just going to pick a number for x. And I'm going to pick a number that's like not too complicated. So 0 is often a nice one. So now I'm just going into my equation with that 0. So I'm saying y is equal to 2 times 0. I'm putting that in for the x, plus 4. So now I can do the arithmetic and see what y has to equal when x is 0. So if x is 0, 2 times 0 is just 0, plus 4. So y is equal to 4. So coming back over here to my table, when x is 0, y is 4. So that means that the point 0, 4 will be on my line. And what I'm going to do, I'm just going to go ahead and sketch over here what that's going to look like. So kind of a rough sketch, but we'll give you the idea of how to do this. So let's say I have my x and y axes. So this is always the x. The vertical one is the y. I want to plot the point 0, 4. So that means I'm going over 0, up 1, 2, 3, 4. So that is the point on my line. So this is the point 0, 4. I'll just label that so you can tell where that came from. Maybe I'll use a different color for the next one. So I need 2 points. So I got this one. Maybe I'll try when x is equal to 1, because again, that's another like small number, not too complicated to plug in. And I'm just going to do that same equation again. So y is equal to 2 times 1 plus 4. So I'm putting this in for my x, still following the format y equals 2x plus 4. So this means that y is equal to 2 plus 4, or y is equal to 6. So when x is equal to 1, y is equal to 6. So I also have the point 1, 6 on my line. So I'm going to go over 1, up 1, 2, 3, 4, 5, 6. So this is the second point on my line. And now I just have to connect those. I'll label that like I did before. So this is the point 1, 6. Connect these with a good straight line. So if you were doing this on paper, you'd want to use like a straight edge or something. If you're doing it, depending how you're doing it, you want to just make sure you get a good straight line. That's not exactly a great straight line, but something like that. The arrows on the end just indicate that this goes on forever. So this will put, by continuing that line forever, you will find every single point that can possibly make that equation true, whether it's a fraction, a decimal, a negative, a positive. So that's the basics. It's just as long as you can figure out 2 points on the line that make that, or 2 points that make that equation true, you are graphing the line. I'm going to get into some more details because when it's in a form like this, there's a little bit of a shortcut way too. So we can use what's called the slope and the y-intercept. So if we have a line in the form y equals mx plus b, which is what we have. So we've got the y by itself. We have a number right here in front of the x, a coefficient to the x. And then we have a number by itself over here, which is the constant. This coefficient of x tells us the slope of the line. This constant here, the number all by itself, like the mx plus b portion, this tells us the y-intercept. Kind of more specifically, the y-intercept is when x is 0, y will be equal to b. So this is the same exact equation we had before. We're just going to approach it in a slightly different way. So here I'll start with the y-intercept. So I'm going to start with the y-intercept, which we can see from the format here is 4, meaning that we have the point 0, 4, which may be looking a little bit familiar from our earlier graph. So I'm going to go, in fact, I'm just going to do this one a little differently. I'm going to put in some numbers first, just so you can kind of see things set up. So this is +1, this is -1 in the x direction, this is +1, -1 in the y direction. So the point 0, comma 4 is x is 0, and again, x-axis, y-axis, 1, 2, 3, 4. But now instead of finding another point from the equation like we did before, I'm going to say this slope that I have, this 2, is my slope. So then I'm going to use the slope to basically count my way to the next point. So the slope of 2, and I have this little description over here. So slope is change in y divided by change in x, sometimes described as rise over run. So slope, which has the symbol m, so the slope, which is m, is equal to 2. Because like this is really kind of a fraction format, rise over run, like these are all describing fractions. So instead of just writing this as a 2, I'm going to put it over top of a 1. So we can always put 1 in the denominator and it doesn't change the value. So what this is, the way this is now helpful, and I'm just going to come over here. So we have 2 over 1, which is telling us we're going to go up 2 because it's positive, so positive is up, and right 1. So up and right are in the positive direction. I'll just make a little note of that. So up and right are positive, and down and left are negative. So from this y-intercept, and that's the key, we're going to use this as our kind of our starting point. I'm going to count up 2 and right 1. So I'm going to go up 2 and 1 to the right, giving us the exact same point we had in the other graph. And again, you wouldn't necessarily have to find the exact same points. The key is that the line that's determined is the same. So when I connect those, and I apologize, I don't know why this is not drawing a straight line on my screen, but you would connect those with a straight line. And that gives you the picture of what that line looks like, arrows on the end to show it's going on forever. So that's another great way we can graph a line, especially if it starts out in this form, that y by itself, a number multiplying by the x, plus b, plus that constant. So that's another way you can do it. And the final way I was going to show here is using both the x and the y-intercept. So we've used the y-intercept. We can also think about an x-intercept. So basically the y-intercept means when x is equal to 0, what is y? In this case, we already kind of know, but I'll just go through it again. So if x is equal to 0, it means we have y is equal to 2 times 0 plus 4. So y is equal to 4, just as we found before. But then we're also going to do, so this is our y-intercept is at 0, comma 4. So it's always x, comma y. But let's also find the x-intercept. So the x-intercept means that when y is equal to 0, so we now have a little trickier equation to solve. 0 is equal to 2 times x plus 4. So we have to do a little more algebraic manipulation here. I want to get the x all by itself. So I'll do that first by subtracting 4 from each side. So 4 minus 4 is 0, so that's canceled out to 0. On the other side, I've got a negative 4 is equal to 2 times x. So again, I want to get x by itself. 2 is multiplying. I'm going to have to divide. So when I do negative 4 divided by negative 2, be careful with your rules of positives and negatives. We get negative 2 is equal to x. So this means that my x-intercept is negative 2, comma 0. So the x is negative 2. The y is 0, and that's going to allow me to plot this line in a slightly different way. So it's going to be the same line, but we actually do have some different points this time. So we have 0, comma 1, 2, 3, 4, and we have, so this is our y-intercept, and then we have negative 2, so we're moving to the left, comma 0. This is my x-intercept. And then I'm going to connect those points with a line. Again, it would be my attempt to draw a straight line, but not so perfect, but something like that. So all three of those lines are the same line. We just found some different points to connect them. when the equation is looking like this, I think slope-intercept is the easiest way to go. When an equation looks like this second one down here, so this is a new equation. I just wanted to show this because this is more suited, I would say, to the x and y-intercept. So if we want to find we'll start with y-intercept first again, just because that's what we've been doing. So if we want to find the y-intercept, that means put 0 in for x. So we have 3 times 0 minus 2y equals 12. Kind of a little shortcut. 3 times 0 is just 0. So this is just going to be gone, essentially. So we're really trying to think about negative 2y equals 12. Divide by negative 2. So y equals negative 6. So we know that we have the point for this line, 0, negative 6, to plot. I think maybe what I'll do is just go to a new page so I can do this better. So I'll just rewrite it there. So we've got 3x minus 2y equals 12. What we just found is that when x is 0, y is negative 6. So we have that point to put onto our graph. I'll just do. And again, here's my x-intercept, my x-axis, here's my y-axis. I have the point 0, negative 6 to plot. That was my y-intercept. And then I'm going to find the x-intercept too. One thing I wanted to point out too, this x and y-intercept, this is for any shape. Like we're focused on lines here, but you can find the x and y-intercept for a parabola, for a circle, for whatever kind of shape you're needing to graph. All right, so 3x, minus 2y equals 12. Now I want to find the x-intercept. So the x-intercept means I put a 0 in for y. So then I've got 3x minus 2 times 0 equals 12. Again, little shortcut. I can just say that's just a 0, so I don't need to think about that really. 3x is equal to 12. To get x all by itself, divide by 3. So x is equal to 4. So that means that we have the point 4, 0. And this is my x-intercept. So I'm going to go 1, 2, 3, 4. And now connect those 2 points. Again, ideally with a straight line. Mine is probably not going to look so straight, but something like that. And that's what this line looks like. So you can see it's a different line from the other one. It has different x-intercept, different y-intercept. Probably has a different slope. So you can see all these differences between the two. But the key was, again, find 2 points, connect them with the straight line. So hopefully that helps clarify some things and give you some background with graphing lines. Thanks a lot.